So, hello everyone, welcome to yet another episode of the SPACINNOVA Podcast series. Today we have with us Mr. Red Boumghar, who is the founder of Parametry.ai, an active speaker on artificial intelligence and big data, and someone who has worked in the domain of blockchain for space traffic management. So, today's podcast has immense value, so stay tuned for the whole podcast, and I hope you learn a lot from this podcast. Welcome Red to our podcast.
Thank you for having me.
First of all, we would like to know more about you. Like, what exactly you do? Like, what exactly you work on?
Thanks, Jit. I'm a PhD in robotics and embedded systems. That may sound very nerdy, but I'm also project manager and community enthusiast. I'm an open source contributor. So I guess that would sum up who I am. I worked in many different places, and including working for the French National Space Agency, also for the European Space Operations Center, and as well as the European Central Bank, which is like not space, but related to project management and machine learning at some point. That's mostly what I do. And today I have my own startup, which is called Parametry.ai. And we do blockchain and AI for space, and as well as providing cloud services in Europe.
Oh, great. So you are an active speaker on AI, right? So we would like to know, what do you think about AI in space tech? Like, what are the applications of artificial intelligence in space tech?
Yeah, you have a lot of them. I guess a lot of them emerge from Earth observation. So 10 years ago, I was working on satellite imagery, and most of the applications in AI, and it was statistics and image analysis, as it was called before, but then it moved on, like convolution neural networks and detecting different things in images. So the goals were to detect roads, buildings, to actually reconstruct the city in 3D and map the texture that you would view from space. So there's a lot of applications in detection and identification of objects in images. So that's a big part of AI in space tech, I would say. And then things have been pushed to be smarter and smarter. So instead of just detecting objects, you actually say what those objects are doing. So in actually detecting sceneries, so like there is a fire and it's a natural fire, or it's a fire from a conflict, for instance, or there are floods, and you're trying to understand the changes in images and their impact, eventual impact on society or nearby habitations. But that's like the Earth observation part. But then you have the outer space, the space exploration part, but also like in between you have the space operations, which is still like the backstage of everything. And there you have a lot of things happening in health status monitoring for a spacecraft and for whatever asset you have in space. It goes from a satellite to a flying robot assistant on the International Space Station. So things are pretty fun on this stage. And at Parametry.ai, what we do, we are actually we're trying to commercialize an open source tool where I'm one of the main contributors. Where we are trying to understand anomalies and explain them and prevent them in a rather new way. So we're using deep learning for that. But there are amazing applications for space exploration because we want to push autonomy. So let's keep track on that, I guess.
So you can also explain, if you can explain in a better way, like what you guys do at Parametry.ai, like apart from the anomaly detection, what else you guys are trying to implement in Parametry.ai?
Yeah, so this anomaly detection is kind of a follow-up of research I did at the European Space Agency. But what we do is we also do blockchain for space. So in creating a space mission, you have so many people, so many stakeholders involved that it's a project management challenge, I would say. So we're trying to see how we could use blockchain to encode and enforce the business logic that are happening between the stakeholders. So we're using smart contracts for that. So this is a very early stage research, but we're doing a pretty good advance. We call that chain exochain. So where we actually have an exoskeleton around the project that helps you build the project. So that's what we do. So we do a blockchain in space for that. And we extended that blockchain project with a new project that we just been awarded, which is a blockchain ecosystem for a consensus mechanism to organize the smart orbit. I can tell you more about that if you want. That's a fun part.
Okay, so you were talking about blockchain, right? So there is a lot of speculation about blockchain in India and around the world. Like people are very speculative about blockchain. Like the word seems itself fascinating, but can you explain like what is blockchain in general, like a very general definition where a layman can understand like what is blockchain?
Yeah, sure. So it's true. It's truly difficult to understand what it is when you're just listening to the news and things like that, because mostly they are focusing on I would say the things that make stories. But blockchain is a technology. It's not a buzzword. So it's a chain of blocks. So and then it's supported by two different things. So you have this distributed ledger. So it's a distributed database of actions that have been occurring on that network, which is called the blockchain. We would say blockchain or network, either way. And so this is a distributed database that on Bitcoin it's managed by LevelDB. It's the technology behind. And then you have the blocks, and the blocks are signed and attached together with their own signatures, and they are validated. And on Bitcoin, so it's validated thanks to proof of work. So in proof of work, you have actually to crack the code of a hash, a specific hash that should start with a certain number of zeros. And the more zeros you have, the more difficult it is. And that's what defines the mining process in Bitcoin. So once somebody has found the right hash or a working hash for the block with a few information they can change in the block, then it can be added to a chain, and then other people can just check that hash would fit that block, and then that's it. And this process is very quick, and then people kind of validate blocks of others, miners like that, and so it goes on like this. So the thing is that in Bitcoin and as in many other blockchain, this process of validating is not really settling the transactions, because you could have somebody actually validating at the same time. That's the problem with the distributed system. So what's happening is that you could have forks that may be going into too much details, but you just have to retain that. Once you make a transaction, it could be passed and executed, but it will be settled only when the blockchain actually ages a bit more. So, but Bitcoin is the first generation. So really like this proof of work, which is in a way a technological tour de force in how it managed to, make people from many different places not know each other and actually work together in making transaction trustable. This is kind of wonderful just by the technology. But then people have worked on the second generation blockchain, which actually includes smart contracts. So in Bitcoin, you had a little place for codes, which the OP code, which is very small, so you can't do much with it. But then on second generation, it was extended to many different functions, and smart contracts were introduced. So in smart contracts, you can do many more things. You can check many more like preconditions for a transaction to happen. And when I'm saying transaction, I'm not just talking about financial transaction, meaning that I'm moving values from one place to another with preconditions. Like I'm moving values from me to a supplier in exchange of receiving something, for instance. But no, it's more things like I'm just proving everybody I'm holding something, and this something is a piece of art. So you have NFTs at some point. This is the second generation blockchain. And then you have third generation blockchain, which is trying to optimize that process, this proof of stake. So where actually validators on the network don't actually mine anymore and consume a lot of energy, but they actually elected by the stake that they put on the blockchain. So their incentive is to be benevolent and do the right thing, because if they don't, then they will lose their stake. So they don't want to do that. They don't want to lose their stake. So the things happen right like this way. And there's also like an election process from a blockchain to another. You can have different processes. And if you're interested in third generation blockchain, I invite you to look at Algorand and Cardano. Those are two nice projects I like to look at how they evolve. And one other thing they bring on the table is the sustainability of the projects, of the whole ecosystem. So they kind of have kind of an automated treasury where the people can participate in the treasury, but also in making proposals, and they can get funds to actually develop those proposals. That's really nice. So I like the third generation because it's also pushing the distribution a bit further. So which is very nice for space where assets might not be all connected all the time. So and that's a great challenge when you want to synchronize and reestablish a single source of truth. Well,
okay.
Yeah, in few words, that's what blockchain is.
Yeah. So let's break it down. So if let's say anyone wants to start with blockchain, right? So what are the hard skills they need to learn in order to start with blockchain?
I see. Well, it depends. What do you mean by start with blockchain? Do you mean like interact with the blockchain, which could be different by being a developer on a blockchain?
Like learning the technology.
Yeah.
Like he or she's a complete beginner and they want to start with blockchain. So what are the hard skills they need?
So I guess I would always recommend to actually take part of a blockchain project. Would that be a gaming project or anything? Because as of today, it's still a bit hard. So it's hard, but also it helps you understand how this works. So first you have to have a wallet, so something that manages your private keys. If you really want to go fully decentralized, or you use a platform that actually manage the keys for you. So what we talk about custody of your keys and custody of your accounts if you're on a financial platform. So once you do that, you actually understand what you can do, what's happening, and then you go on the other side where actually you're becoming a developer when you want to write those projects and you want to write those codes, those smart contracts. And there you have many different places to go. So you have many courses on the internet. There's one nice course is discovered quite recently. It's called Crypto Zombie. It onboards into the Solidity language, which is the foundation of Ethereum. But then you can go towards the third generation blockchains where they actually try to have more classical languages like Python or C++ for the first, I would say. But once you do that, you realize you need a framework. So, and there are different frameworks. I would recommend Troubleshoot. It's kind of nice. Or Hard Hat. I find it simpler. Hard Hat would help you to set up a project for smart contracts, but also where to put your smart contracts, how you compile them, how you get the artifacts, how do you push them in a local blockchain to try them, and that's what will go on. So now I guess the natural evolution is that you start to do that, and you start to do simple contracts, voting contracts, and then you start to increase your skills, and then you start to represent assets that you have in real life in digital form, trying to see what kind of functions those things have. My bag, for instance, can hold things inside, so it's kind of the function of the bag. The computer has another one. So yeah, that's there. You start to go there. You start to be fluently speaking smart contract and make sense of things. You have to keep an eye on standards because there are many things that are already done. So don't try to redo the wheel. There are many standards. Like if you want to do tokens, there's this ERC20. I mean, you have different variants that came later, but ERC20, you would hear it a lot. ERC20 compatible token. It's usually very useful to be on Ethereum, but also cross-chain if you want to do that. But then you have ERC, which is like Ethereum request for change, and it's actually defining a standard It's ERC 721, which is the definition of a non-fungible token. So a euro or a dollar are fungible, meaning you can split them and exchange them against another euro, while a non-fungible token is really like this. The pieces of art represent well the non-fungible token. You can't really split a painting. You can't really exchange it to another one because it's unique. And then you have the ERC 1155, which is very popular because they're still like non-fungible tokens, but there can be derivatives. So and they're used a lot in gaming. When you have outfits for avatars, a jacket have different colors, different buttons. This is metadata that can be dynamically changed and create a new token. So yeah, that's more or less what you'll go through if you want to onboard the blockchain development.
Great. So how can we implement this in space industry? Like what are the application of blockchain in space industry? You can also talk about your projects. What are you guys currently working on? You are working in smart contracts for satellites, right?
Yeah.
And yeah. So can you just explain that?
So in the space industry, you have different things happening. But on our project, what we're doing is actually we're trying to represent the different components in the space mission. So imagine a space mission, to simplify, with one spacecraft that goes to visit Jupiter, for instance. The spacecraft has to be equipped with different things, so solar panels, batteries, thermal subsystem to keep it warm or cooler when it's needed to, and then communication system, etc. Those components, they are made by different stakeholders. So what we're trying to do is actually represent those components from those different stakeholders. Here we have dynamic metadata. Sometimes we call solar panels that look like another solar panel, but they have different specifications. So it's pretty convenient to represent them like that, like a ERC 1155. And then what we do is actually we onboard them in a what we call a system engineering blockchain. So a blockchain that is used to represent what we call models in a model-based system engineering. So system engineers, they already modeled everything. So we're trying to use those models and represent them on the blockchain so that they interact together. So if you plug a solar panel, it gives a certain amount of power to your spacecraft. Certain amount can be used to charge the batteries. Then the batteries are used to feed your camera or different things. So what we're trying to do is trying to see if everything fits together. So the system engineers, they already have algorithms to check, optimize the spacecraft building somehow as the mission constraints evolves. And what we're trying to do is to track and audit what happened during the design phase, the co-design phase. So it's kind of an evolving ecosystem, or where everybody has to move together to build the spacecraft. So because we're in space and everybody depends on everybody on this every component depends on every other component. So when you have to be launched, you have to respect a certain weight, and when you're in space, you have to respect a certain energy consumption. So everything relates to everything. So we're trying to also enforce certain business logics to avoid things from happening at a later stage somehow. And yeah, that's pretty much what we're doing on this one. So there's a lot also of digital identity, because we need to identify the engineers making actions on the blockchain. So we are using universal profiles to do that. So you actually don't act on the blockchain as your own address, but you act as a universal profile. You have rights to use. This is a private blockchain use case, I would say. Yeah.
Okay, great. This sounds pretty new, right? So is Parametry.ai the only company who is working on this, or there are other companies in the Europe?
Pretty much. This is it's quite amazing, actually. This is in Europe, we are the only one. There is another company with NASA, which has been doing that. So we are with ESA doing the same in Europe, pretty much. We've been focusing on zero knowledge proof, while the others have been focusing on really representing the models. So we are actually complementary, using their work. I mean, trying to to work together, I would say. The nice thing is that NASA and ESA almost started at the same time on this, so it's fun how it evolves, I guess. So I just said the keyword, which is zero knowledge proof. So I didn't talk about it, but when you actually build a space mission, sometimes you have components you can't know how they work exactly, but you still have to plug them with the rest. So you need like external validators to tell you like this component can be plugged there and will respect the weight without knowing the weight of that thing eventually. So we are trying to use zero knowledge proof, which is a process to help you know if your third party really knows what they're doing without sharing the information on that component. So that's pretty convenient in certain cases, and I guess something we can't control. I mean, we can't avoid that, so we have to go through that. And it's very nice, a very nice process actually.
So you also told that you're using blockchain to manage the space traffic. Like, what do you exactly mean by that? How are you managing the space traffic using the blockchain?
So space traffic is part of another project that we have. So we won another project with ESA again, and so it's a more of I would say blockchain for managing what's in orbit. So imagine in the near future where you have like satellites who can process AI algorithms and becoming smarter. So instead of just dumping down images, they actually send you prepared maps. So maps are a collection of images that are recollected together, mosaic together, geometrically coherent, etc. And this can be done on board now. So this is more and more possible now. So in the near future, things are going to evolve. What the processors that are going to be on board could do more. So we are living in this ecosystem where things are possible in orbit, where satellites can service other satellites. You start to have some kind of discrepancies because you have new satellites who can provide services to others, and then start to have like very good communication links between them. So we are trying to see and find a consensus where also on ground and orbit can collaborate to process everything together. And I'm talking about Earth imagery, but a lot of things can happen for space traffic management. So space traffic management is a very subtle problem because you have in the context of two spacecraft which are alerted to eventually collide, you have a high risk of collision. Then you have to act, and who has to act? This is difficult. So one of the spacecraft mission has to move, change orbit slightly. The thing is that when you do that, you actually use a special tank, usually in your spacecraft, which is defining the end of your mission. So now if you can't bring your spacecraft down thanks to this tank, this reserve of fuel, then you're out low somehow. So you have to be able to have enough fuel to bring your spacecraft down. So you get me that if your fuel reduced to that minimum amount, your mission is over. You have to just go down. So it's very difficult to know who has to move because there are many things, many factors in place. And before we know who has to move, we have to really validate the space traffic alert, so the collision alert, collision message that everyone receives. So we have a set of stakeholders that have to interact in a blockchain we're proposing. Where they have to find consensus on first, is there a real risk, and second, who has to move. So this is where it's getting interesting.
I guess this is a very great application, and I've been reading about blockchain for a few days now. So blockchain is a technology similar to the internet back then, right? So like there is a lot of speculation and not conviction. So if we think that if we can bring conviction to this technology, do you think that this can also revolutionize the world as the internet did back then?
Yes. I would say yes and no. I'm involving in this. So my startup is kind of the first doing those kind of things. We're pioneering many things. but you'll be surprised how we evolve. We're actually very skeptical, and actually people like that. So we are not like just pushing blockchain because this is new and we just want to use blockchain there. We are pushing blockchain in problems where you have a problem of trust, because you need to trust, a collision avoidance message, for instance. You need to trust people doing a transaction for you. So there are many things where trust is super important. And we're also like evolving in an ecosystem where by nature it's very decentralized. So space is multi-governmental. So you may have heard of many different missions. Sometimes you hear it's only NASA doing that, but actually it's not true. So you have a huge amount of stakeholders and collaborators that actually built the mission. And even if one agency launched it, it's a collection of collaborators. So trust and decentralization are two important factors where we see blockchain as a useful medium. And usually we like to call that a middleware for business logics. So it's kind of helping and setting up that space where you can actually encode and enforce the business logics.
Great. I guess the things your company is doing right now is very new and very fascinating to us, because I don't know any company in India who is working on blockchain plus space. So at Spartificial, we are currently implementing artificial intelligence into space technology, right? So we are also thinking to pivot towards blockchain along with that. So thank you for this valuable podcast, and your value providing us with your valuable knowledge. You have been attending different conferences around the world and giving lectures on AI and big data and data science. So, what was your observation? What was the output regarding AI from the people you interacted with?
So yeah, as we're trying to explore space, what we're trying to do is to understand the solar system, to understand how Earth formed, how life started to exist, so that we could understand where we can find other forms of life as we know it. We need automation. We need robots to do the job. We're still onboarding and embarking in amazing missions where we want to send astronauts very far, or we want to send people to Mars. But those environments are very adversarial for a human being. So we are sending robots for now. On Mars you have many robots. But we want to send robots on moons of Jupiter. We want to send robots as far as we can, and we can do that because they are robots, But they need to have more autonomy. So they need to have more autonomy in many ways. So they need to have more autonomy in their decision making and their actions, because the communication links are they take time. So you can't just jeopardize a mission just because you're waiting for the ping, somehow the autonomous asset has to decide by itself. So in order to increase autonomy, you need AI. So, and that's why AI is so much pushed everywhere, in every corner of space missions and space exploration. Once you do that, you actually push things further. So meaning that you want to send bigger and bigger missions. And farther missions. I even heard concepts of missions going very far, like at almost like 600 UA, so astronomical units, AU. I guess AU in English. I don't remember. It's the distance between the Earth and the Sun. So you have to go like 650 times that distance away from the Sun. So you can actually use the Sun as a micro lens. So use gravity to actually bend light and actually use the Sun as a lens and observe things that are much farther with a huge lens. So this is like a mission where, it would take like 50 to 100 years to reach the point eventually. And so the mission is made of several spacecraft that have to interact with each other. But you can't be the middle person in how things should be planned and scheduled and done. So you prepare things in advance, and you can't just prepare a static plan. you have to use AI. And planning and scheduling is another important topic in AI development. And then of course anomaly detection and understanding and anomaly correction is a very important one. In those spacecraft, but also in a space station, like when you have human beings, you want to have those kind of systems to be able to act in advance and in timely manners to save the people inside and to keep them alive and in good health. So that's one thing. And when you have to send more larger missions, then you need to build things in space. And so then you start to have this space economy starting to really take shape, where you have robots that are actually going not to explore, but to mine. So they have to explore, actually find the minerals and then extract them, and then bring them into a station that will build things. So this is kind of the classical Earth supply chain put in space. This might be very different in the future, but this is how you can imagine that. So, and we're starting to have like 3D printing in space. So, AI is not evolving alone, it's always evolving with an application. So, and you have also like AI used for mining. So how do you break rocks the most efficient way? So you save consumption of energy and those kind of things. So this is, you have machine learning everywhere at some point. So, and then in this future, you have like self-made robots that actually do their own exploration, actually reporting to human beings on where are the next best spot to explore somehow. But things are, different technology are involved. It's not just AI. You have many things that evolve together. AI, you even have calls at ESA like to use AI in optical communication to make them more efficient. But then you need eventually we have quantum communication, which challenge everything. So you could directly communicate, instantly communicate with something on the other side of the solar system. So that may happen at some point. So yeah, I'm looking forward to that future actually.
Yeah, the future sounds wonderful, I guess. So, thank you very much, Red, for this wonderful podcast. I hope our audience will generate value from this. I hope that we are also pivoting towards blockchain in space, like we at Spartificial are also planning to pivot towards blockchain in space. So, we'll definitely get back to you regarding that. But
Nice,
this
great.
was this was a great session, and loved how you talked about blockchain and Parametry.ai. So thank you so much for this podcast.
Yeah, thanks a lot for having me. This is great, and keep it up. This is a nice podcast.